Firefox может. Да, Firefox работает.
Не надо Firefox. Это же браузер запускать. Зачем Firefox? Это простая, быстрая программа. X-Newt надо открывать.
Попробуем Firefox. Если нет, тогда уж пройдем дальше. Я люблю Firefox. О, вот он пошел. Вы видите, она идет, вот эта эволюция идет. Вот она все идет сюда, 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 и вот она почти дельта-функция. Вот мы начинали оттуда, и она перешла сюда полностью. А нумеровка остается единичной при этом. И это решение численного уравнения эволюции для этой штуки. Это не обман. Так, где мы там были? Здесь. Так. And now what is we have for experimental data here? And the result, for example, of fitting experimental data, there are a lot of experimental data. You see, this is fit of using QCD, but not at one loop, but I think it is at two, maybe at three loop. But nevertheless, the quality of description is fantastically good. All data are inside of error bars. And why we speak about a logarithmic violation of Bjorken scaling? Because if Bjorken scaling is exact, that means that it's not dependent on Q squared. So this will be not the case. Only straight lines parallel to x-axis will be. But in experiment we have this. So it depends on Q squared, but logarithmically, by logarithmically, because alpha s depends on mu squared or on Q squared, logarithmically. This, for this reason, it named logarithmic violation of Bjorken scaling. And QCD deliver you explanation why it is like this. Now about E plus E minus 2 hadrons. First, let us speak about what we can say about vector current correlator of two vector currents. From Lorentz invariance, we know that it should be only transverse. So we have this invariant amplitude P of Q, invariant correlator. Let us discuss what is the dimension of this invariant scalar function. We know that G mu, the dimension of G mu is just dimension of psi squared, so it is m cubed, because spinor have dimensions 3/2. So dimension of P mu is just dimension of this minus integration. Integration is m4, because we integrate in 4 dimensions, so it is m squared. So what is integration of when, if we know that this object is m squared, what is the value for dimension of P of Q? It is just 0, because here is just m squared kinematical variable, so it has 0, so it is dimensionless variable function. Sorry. If we put inside unity in between currents, we put it in for T product, so we have two parts, one for Q0 positive and now for T0 negative. Sorry, not Q0, TT for time variable. And if we put all carefully, we obtain this relation. And here will be integration over T of these two exponents. If you remind yourself Sochotsky formula, that this integral is just P of delta function plus minus I and mean principal value of unity over X over I alpha, then you understand that if you take into account only imaginary part of this guy, you obtain this nice expression. Why it is so nice? Because you will see in a few minutes, in a minute, 1 second, that then you can say that this guy depends only on Q squared. It not depends on Q0, because here is absolute value of Q0. Right? That the function of some positive number is just unity. And what is interesting to us in respect of E plus E minus 2 hadrons, this object, this spectral density, is one-to-one related to one photon QED description of its process E plus E minus 2 hadrons. Why? Because you see it just goes from E plus E minus to virtual photon and then to some quarks, and then hadronization to hadrons. If you sum up all possible states, it will be just cross-section. So just an optic theorem. Imaginary part is proportional to total cross-section. And if we put some coefficients inside, we see this relation between cross-section of annihilation and our spectral density rho. And usually people don't like to speak about rho, but they instead like to speak about so-called R, ratio of S. And this ratio is just a ratio between E plus E minus cross-section and E plus E minus to mu plus mu minus. And my question to you, why to mu plus mu minus and not to E plus U minus? Can anybody answer why this is the normalization factor for this ratio, but not E plus E minus? Can anybody say something? The question is very simple. If we try to write it down, where is my chalk? Yes. So you have this process, E plus, E minus, and here is your virtual photon, and then it goes to quarks, quark, anti-quark. And we want to calculate something in QED which is completely like this. Usually people select this process. This is mu plus, mu minus, but not E plus, E minus. And my question is why? But why not E plus, E minus? And speak about mu plus, mu minus.
Because we don't want in T-channel.
Exactly. The answer that in this channel there is no T-channel contribution. And in this we have. So in this channel we have also this diagram. This. So E plus goes to E plus, E minus goes to E minus. So if we would normalize our cross-section to this guy, it will not be proportional without coefficients to this object, which we just want to understand, to calculate. But if we normalize to this guy, there is no T-channel contribution. This will be completely the same. The only difference in this is just numerical factors. So we answer this question. So how we can calculate it in QCD at 3 level? I told you that it is possible to do using optical theorem. We just put the same diagram and square it, квадрируем их, чтобы получить сечение. And then we have in between just quarks, and quarks of different flavors and from different colors. So if it will be just one quark without any color, what would be the answer for this ratio? If we have in the nature only one quark of one and one color, what would be the difference between these two processes? One. Yes. If the electric charge of this quark would be unity, then definitely one. But because we have different flavors here, yeah, we have sum up. But what we should sum up? First of all, there are colors, different colors, so it will be multiplied by NC, and different charges, because charges of quarks are not unity, like in like in positron and electron case, but they are different. I showed you in the very beginning that there is 1/3 and minus 1/3 and 2/3 of electron charge. So we will see. It's just the answer. At the 3 level, it is like this. It is a number of colors and sum of squares of electron charge. If you put inside only three flavors, I mean this U, D, and S, then you have here 3 for color, and this 1/3 for D, 1/3 for S, and 1/9, 2/3 squared for U. And if you sum up it, you obtain 2. So the answer that if S quark can be taken into account, so if you have energy enough to generate S quark, then you have for this ratio 2. Please, George and Z did this calculation, but not at 3 level, but taking into account first non-trivial radiative correction, one loop correction. It is appeared just unity, just alpha S over pi. And for free light quarks, at approximately 1.1 this value, so it will be not 2 but 2.2. And what we have, and at Trieste workshop at spring 1974, Richter informed that this ratio, which we measure in slug, people start to be very pessimistic about QCD, because in QCD it is approximately constant. But after some time it appears that this is due to some resonances related to C quarks, And it is the whole picture you see here. Just you see in this ratio some contributions of mesons, but here it is approximately 2 or 2.2. Yeah, but